Introduction. Artificial intelligence, AI, is a field of computer science that deals with the development of intelligent machines that can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision-making, and language translation. AI is a rapidly evolving field that has the potential to transform every aspect of human life, from healthcare to transportation, education, and entertainment. In this post, we will explore what artificial intelligence is, how it works, and its applications and impact on society. What is artificial intelligence? Artificial intelligence refers to the development of computer systems that can perform tasks that typically require human intelligence, such as learning, problem-solving, decision-making, and perception. AI systems can be classified into two broad categories: narrow or weak AI and general or strong AI. Narrow or weak AI refers to systems that are designed to perform specific tasks, such as facial recognition, speech recognition, or recommendation systems. General or strong AI, on the other hand, refers to systems that can perform any intellectual task that a human can, and can learn and adapt to new situations in the same way that humans can. How is artificial intelligence mark of human achievements? Artificial intelligence, AI, is considered a mark of human achievement for several reasons. First and foremost, AI represents the culmination of decades of scientific and technological research, innovation, and development. It is the result of the collective efforts of countless scientists, engineers, programmers, and other experts who have devoted their careers to advancing our understanding of how the human mind works and how machines can be designed to emulate it. Secondly, AI is a testament to human creativity and ingenuity. It is the product of human imagination and the ability to conceive of new possibilities and explore the frontiers of what is possible. It reflects our desire to push the boundaries of what we know and to create new forms of intelligence that can help us solve some of the most complex problems facing our society today. Thirdly, AI is a reflection of our unique ability to learn, adapt, and evolve. Unlike other animals, humans have the ability to create and use tools, to communicate and collaborate with one another, and to build upon the knowledge and experience of previous generations. AI represents the culmination of this evolutionary process, as we have used our collective knowledge and expertise to design machines that can learn from experience, adapt to new situations, and improve over time. Finally, AI is a testament to our desire to understand the nature of intelligence itself. For centuries, humans have been fascinated by the mysteries of the human mind and the nature of consciousness. AI represents the latest chapter in this quest for understanding, as we seek to unlock the secrets of intelligence and consciousness through the design and development of intelligent machines. History of artificial intelligence? During the 1960s and 1970s, there was a lot of hype around artificial intelligence, AI, with some researchers and companies predicting that machines would soon be able to perform a wide range of tasks better than humans. This optimism was fueled by the development of new AI techniques, such as rule-based systems and expert systems, which were able to perform simple tasks such as playing chess and solving mathematical problems. However, this optimism was short-lived, as progress did not meet these lofty expectations. Many of the early AI programs were slow, brittle, and unable to deal with complex real-world problems. As a result, there was a backlash against AI, and funding for research dried up. This period of disappointment and disillusionment became known as the AI winter, as many researchers and companies abandoned the field of AI in favor of other areas of research. However, a small group of dedicated researchers continued to work on AI, developing new techniques such as neural networks and machine learning, which eventually led to a resurgence of interest in AI in the 1980s and 1990s. Despite the setbacks of the early years, the history of AI is marked by a series of breakthroughs and advances that have enabled machines to become increasingly intelligent and capable. Today, AI is being used in a wide range of applications, from self-driving cars to medical diagnosis, and the field of AI continues to evolve and grow. However, the early hype and disappointment of the 1960s and 1970s serve as a cautionary tale about the dangers of overpromising and under-delivering in the field of AI research. How does artificial intelligence work? Artificial intelligence works by using algorithms and mathematical models to analyze data and make predictions or decisions based on that data. These algorithms are often based on machine learning techniques, which involve training a model on a large dataset to identify patterns and relationships within the data. Once trained, The model can be used to make predictions or decisions on new data. Some common machine learning techniques include supervised learning, unsupervised learning, and reinforcement learning. Unsupervised learning. Unsupervised learning is a type of machine learning where the algorithm learns from data that is not labeled or classified in any way. In other words, the algorithm is given a dataset without any predetermined categories or targets, and it must find patterns or relationships within the data on its own. Think of it like a teacher giving a student a bunch of objects without any labels or instructions, and the student must group the objects based on similarities or differences. The student has to figure out which objects belong together based on their own observations and analysis, without any external guidance or feedback. Similarly, in unsupervised learning, the algorithm has to analyze the data and find similarities or differences between the data points, without any predetermined labels or targets. This can be useful in situations where there are no clear categories or labels for the data, or when the data is too complex to be easily labeled by humans. One common application of unsupervised learning is clustering, where the algorithm groups similar data points together based on their characteristics or features. Another application is anomaly detection, where the algorithm identifies unusual or unexpected patterns in the data that may indicate errors or anomalies. Supervised learning. Supervised learning is a type of machine learning where an algorithm is trained on a labeled dataset. Labeled data refers to data that has been tagged with the correct answer or output. The algorithm uses this labeled data to learn the relationship between the input data and the correct output. For example, if we want to build a spam filter, we can use a supervised learning algorithm. We would first gather a large dataset of emails, some of which are spam and some of which are not. Each email in the dataset is labeled with the correct classification, spam or not spam. We would then train the algorithm on this labeled dataset, feeding it both the email content and the corresponding label. The algorithm would use this data to learn the patterns and relationships between the email content and the correct classification. Once the algorithm is trained, we can use it to classify new, unseen emails as spam or not spam based on what it has learned from the labeled data. Reinforcement learning. Reinforcement learning is a type of machine learning where an algorithm learns to make decisions by receiving feedback in the form of rewards or punishments. Here's how it works. The algorithm is given a task and a set of possible actions to take. It then takes an action and receives feedback in the form of a reward or punishment, based on how well it performed the task. The algorithm uses this feedback to adjust its behavior so that it can take better actions in the future. Over time, the algorithm learns which actions lead to the best outcomes and becomes better at making decisions. A simple example of reinforcement learning is teaching a computer to play a game. The algorithm is given the objective of winning the game and is allowed to take different actions, moves, in the game. After each move, it receives a reward or punishment based on whether it has won or lost the game. The algorithm then uses this feedback to adjust its strategy and make better moves in the future. Over time, the algorithm becomes better at the game and learns to win more often. Reinforcement learning is a powerful technique that has many real-world applications, such as optimizing resource allocation, improving recommendation systems, and developing autonomous robots. Uses of artificial intelligence for better tomorrow? Artificial intelligence has numerous applications across a wide range of industries, from healthcare to transportation, finance, education, and entertainment. Some examples of AI applications include healthcare. AI is being used to improve patient care, from diagnosis to treatment. AI systems can analyze medical images to detect diseases and abnormalities, and can also be used to monitor patient vitals and detect changes in health. Transportation. AI is being used to develop autonomous vehicles, which have the potential to reduce accidents and improve traffic flow. AI systems can also be used to optimize transportation routes and schedules. Finance. AI is being used to detect fraud and to analyze financial data to identify patterns and make predictions about market trends. Education. AI is being used to personalize learning experiences for students by analyzing their learning styles and adapting the curriculum to their needs. Entertainment. AI is being used to develop video games that can adapt to the player's behavior and to create personalized music playlists and movie recommendations. Thanks for watching.